have already learned how the electrons in an orbit are arranged in different shells, orbits. Also, the maximum number of electrons that can be accommodated in the first orbit is 2, and thereafter the outermost shell of an atom can accommodate a maximum of 8 electrons. Now, why is it that the atom of some elements like helium, argon, etc. show little chemical activity? To find out the answer, let us understand the concept of valency. The atoms of elements which show little chemical activity are stable. It means that their outermost shell is completely filled, that is, the inert elements like helium and argon. Since the maximum number of electrons that can be accommodated in the first shell is 2, and the atomic number of helium is 2, it is completely filled and is stable. The atomic number of argon is 18, and so the electrons configuration is 2, 8, 8. The outermost shell is completely filled and is stable. Thus, elements like helium, argon show less chemical activity. The chemical activity is determined by the tendency of atoms of one element to react and form molecules with atoms of the same or different elements. Now, what happens if the outermost shell of an atom is not completely filled? There is losing, sharing, or gaining of electrons in order to make the octet of electrons in the outermost shell. Let us take an example of a duet song competition organized in your school. Lily, Sita, and Suhana wants to participate in the competition. Lily and Sita forms a duo, and now for Suhana to participate in the competition, she will have to form a duo. So Sita agrees to accompany Suhana and perform with her as well. In this case, Sita is being shared by Lily and Suhana. Similar is the case when carbon and hydrogen atom are combined. Now, for carbon to fill its shell, it will share 1 electron each with 4 hydrogen atoms and thus form a bond. This is how electron sharing takes place between atoms of different elements. Let us take another example of 2 groups of children. In order to participate in a dance competition, there should be 8 members in a group. Here, Group A has a total of 6 members and Group B has a total of 10 members. We see that Group A has 2 members less, whereas Group B has 2 members more. Now, 2 members from Group B can join Group A in order to have 8 members in each group. Here Group A is gaining, whereas Group B is losing. Similar is the case with elements, say like oxygen. The atomic number of oxygen is 8. So, its outer orbit will have 6 electrons. Now, in order to have 8 electrons in its outermost shell, 2 more electrons need to be gained. So this is what we call a valency. Here, valency is 2. Now, let us take the example of magnesium. Its atomic number is 12. Electronic configuration is 2, 8, 2. We see that For the outermost shell to be filled, 6 more electrons need to be gained. Does it mean that the valency is 6? Well, it could be, but we see that it is easier to lose 2 electrons than to gain 6 electrons in order to have an outermost shell filled. So, in this case, magnesium will lose 2 electrons to be stable. Hence, the valency is 2. So, we have seen that atoms would react so as to achieve an octet in their outermost shell. This is done by sharing, gaining, or losing electrons.